All right, so we got solving inequalities on the agenda today, and we're going to be talking about our learning targets of knowing the 4 types of inequalities and knowing them by different names. So there'll be a few different ways to call them, and you'll be able to solve an inequality for its solutions. Some vocabulary. Obviously, what's an inequality? It's one of those symbols that you see in front of you. Sometimes they have the line underneath it, but know that we're not talking about equal signs today. And then a solution set. Usually with equations, we have one answer. Here we could have more than one answer. So these are all the ways that you can say these different signs. You can say for the top left, greater than, which is the most common one, more than or above. Now the key to this is there's that open circle there. And that open circle is going to be used on the graph, and we'll talk more about that. The less than is also known as fewer than, smaller than, and below. All things that are smaller or below the number that we're comparing it to, also with an open circle. And then we have the greater than or equal to symbol. So it could be one or the other, could be both, or sorry, it wouldn't be both. And this would be less than, no less than, and minimum. Those are kind of tricky for students because those words sound like small, but they actually represent the greater than or equal to symbol. And then we've got the less than or equal to, and just the opposite of what we saw. We're seeing at most, maximum, no more than. So you're like putting a cap on everything, and everything's going to have to be smaller than it. All right? So with these inequalities, let's say if they are true or false based on what we know about inequalities and integers. We've got 7 greater than 3. Head scratcher. Yep, that's true. That is, in fact, a true statement. Next up, we got 3 greater than -4. Any positive number is going to be greater than a negative number, and so that is true. And then we got -5 greater than -3. Careful here, you owe more than you have, right? You owe 5, you actually maybe would only, -3 is closer to 0, is what I'm trying to say. This is a false statement. That can't be bigger since -5 is further from 0. And then the last one, we have 4 less than 4 or equal to 4. Well, it's certainly not less because it's the same number, but because of that line here, this would be a true statement. All right, go ahead and try E, F, G, and H on your own. Pause the video. The answers will appear in just a second. So there you go. Get those answers down, and hopefully we have a better understanding of why we're using these symbols to compare numbers. Now let's take it to the solving aspect of things, and we're going to start simple. 2-step equation. You've seen it 1,000 times, but maybe you don't remember it with the inequality symbol. Well, you do the same thing we did with equations, and that's do the opposite. So if you see -3, we are in fact going to add 3. And I'm going to do it on both sides because I'm using the property of equality. So that's going to give us 4x and then 8. There are times we change the sign. Adding or subtracting is not one of them. So keep it simply greater than or equal to. Common mistake for students is to make it an equal sign because that's what we're used to. Tough to break that habit. Just make sure you're paying attention. Then we've got multiplication, which we're going to undo with division. So we divide, and x is going to be equal to. Now, we divided by a positive. Regardless of the answer, it's what you divide by. If we divide by a positive, this stays the same. So it's x greater than or equal to 2. So how do we graph this? Well, again, back to those words. I have the greater than symbol. Sorry, I have the greater than or equal to symbol. And notice with that, I had a filled in circle. So that means when I put the first point on the graph, I'm going to fill it in because we're including 2. 2 is in the answer. Now, 2 is not the only number in this answer. All the numbers that are greater than 2 as well. So which side of the dot would they be on? Yeah, we're going to the right. So this would be the higher or the greater than side. So just draw an arrow pointing it to the right, and you have represented all of the solutions. All right. That one was pretty easy. Let's take a look at the next one, which has got the distributive property in there. You know, sometimes I like to sprinkle in a little difficulty. So we got 4 minus 2 times x plus 8 greater than 16. I know it's tempting to subtract 4 and 2, but don't do it. Can't do it. Got to distribute first. So negative 2x minus 16. We can bring down the 4. Didn't change that sign. Still greater than 16. Now, some students would just start moving things from one side to the other. I would recommend we combine like terms. We use that commutative property to put these together, and that would make negative 2x. Different signs, so I'm actually going to subtract and get 12. Sign of the bigger number is negative, so it's negative 12, and I'm still greater than 16. I got some audience members here who could tell me what the next step is. They're making the people at home wait. The people at home are very eager to know because they don't want to keep sitting here watching this video. Yes, thank you. We are saved. We had an answer. Add 12 on both sides. They said we're going to bring down the negative 2x, have 28 here, and still keep the sign whenever we're adding or subtracting. That doesn't change. But here's our big moment, because we're going to have to divide by a negative. Maybe you remember, maybe you don't. What happens to the inequality sign when your 28 that was nice and positive suddenly became the opposite sign and is negative? Yes, we're going to have to switch that from a greater than to a less than. And the reason is because I divided by a negative number. I could give you a proof for that, but just take my word for it. That's what you got to do. I changed this problem slightly. Forgot to change the graph, so my apologies. Let's just change these real quick. Negative 20, negative 15. This would be negative 10, and then we'd have negative 5, and then this would be 0. So if you could just make those slight adjustments for me, we could graph this more appropriately. So we have x less than negative 14. What type of circle are we going to have? Well, it's going to be an open circle, because what's different? What's not in our answer this time? Right, which means negative 14, not in the answer. So what is in the answer? All numbers less than 14. What side would that be on? Well, the less than side would be to the left. Yes, so fill this in going to the left. I'm not going to do any more graphing for today. That's it. Just a quick refresher of graphing and more or less trying to show you where the answers lie. Couple of steps. So let's solve some inequalities that have multiple steps and variables on both sides. I'll talk to you about my strategies and show you why I'd like you to try my methods here. But first, the best way to get started is to distribute. All right, not to add things that we can't, but to pass out the 3. So it's 2n plus, well, 3n, right? And then 3 times negative 2, negative 6. So I've distributed the 3. I'm going to do the same on the other side. I'm going to pass out the 2 to everything in the parentheses. That's going to give me 12 minus 4n. Again, save yourself some trouble. Start to combine like terms before you move things from one side to the other. So 2n plus 3n is 5n minus 6 greater than 12 minus 4n. And here we get to a kind of a crossroads where we have multiple options. We can do probably 2 or 3 different things and still get to the same answer. I'm always going to recommend you move the variables to the left. And my apologies. Sorry, we had a typo that I had to fix. So always move the variable to the left. Moving it to the left will keep the variable on the left, and you'll find that that makes it easier to come up with your final answer. I'm not going to follow that rule, and I'm going to show you why it makes it more difficult. Ready? I'm going to subtract 5n, and that means I'm going to move things to the right. So my variable is going to end up over here. You'll see why that's not the greatest move in a moment. But for right now, this is going to 0 out. That makes 0, so we don't have to write it. Still greater than, even though I subtracted, doesn't change the sign, 12 minus 9n. We're going to keep doing what we do and subtract 12 on both sides. Got to follow my integer rules, and that's going to be negative 18, still greater than negative 9n. Now I've got to divide by negative 9 on both sides. Negative divided by a negative makes a positive 2. This is going to make just 1, so that's n. We've heard this before. Divide by a negative, you must flip the sign. So sign gets flipped, goes from greater to less than. But people don't read this as 2 less n. Doesn't sound as good. What sounds better? Yeah, having the n on the left, right? I said that back in this step. Try to move variables to the left when you can. So let's do that. So if I switch the number in the variable, what has to happen to the sign? That's got to be switched as well. Okay? We're going to sprinkle in some fractions. Ready to have some fun? All right, the last thing we want to see is fractions. What can you do with those fractions? You can make them decimals. All right, that might be a strategy you have. Turn them into decimals. I'm going to show you how we can get rid of the denominator. Okay, so good thing is on both sides of the inequality, and that is, yes, an equal to symbol, it's got a 5 in the denominator. So if you put this all in parentheses, all you got to do is multiply by 5, and that denominator will take care of itself. Now, you know, this might be a little difficult or a little tricky for you to see, so I sometimes tell students to break it up into 2, but you got to do it all by the same amount. Okay? So what's going to happen here? I'm going to distribute the 5, and I did that so that this 5 here will go away. So that 5 cancels, leaves us with 4x. I still got to go to the 22, and that's going to make negative 110. All right. Next up, I want to multiply by 5 to get rid of that denominator. So this times 5 will cancel this out, and 5 times 14 would, well, we still have 1x, but 5 times 14 would in fact be 90. No, 70. Whew, having a moment. 70. So now I've got it the variables on both sides, which I'm going to follow my rules. I'm going to take my own advice, and I'm going to move the variables to the left, which means I want to subtract 1x. And so now when I finish with my answer, the variable will in fact be on the left, and I won't have to worry about doing that little last minute switch. So I subtract 1x, I add 110, I have not changed the sign because we have not multiplied or divided by a negative. Had I multiplied or divided by a negative here, I would have had to change the sign. This would be an 8, thanks to my friends in the class. Divide by 3, and x is 60 with the same sign because I'm just dividing by a positive. So let's move on to the last one, and sorry for screaming at you, that probably was pretty loud. We got a stadium filling up with people. I was at a stadium yesterday, and it was filling up with lots of people. So this stadium holds at most, one of our vocab words, 2,500 people. Of the 2,500 seats, 350 are reserved for special guests. We need a little bit more information. Let's think of those as people already in the stadium. Those people that got a special preview, they got in early. So when the doors open, people filled the seats at a rate of 10 seats per minute. And again, these people were already in before the other normal people were allowed to walk through. So let's write an inequality that shows times in minutes that the stadium is being filled, and then we're going to solve that inequality. Well, the 2,500 is the max capacity. At most, which inequality symbol is that? At most, yeah, the one that looks like an L, the less than. So there's the less than. And now on the other side, how do I work to that? Well, here's my rate, 10 seats per minute. So 10 M. And then remember we had those 350 people getting early entry. So they were already in the stadium. So we've got our inequality. They would like us to solve the inequality. I worked through the problem there, just went through the normal steps, used the property of equality two times to see that the number of minutes would be 215. The second part of this is, at that rate, will there be any more people able to find a seat after 4 hours? Well, 4 hours is equal to 60 minutes times 4, and that would be 240 minutes. And